Okay. Hi everybody, my name is Sam Clegg, and I'm from Marmalade, and we're based in London. And we have a team of 5 people here in Dnipro, and this is my first week in Ukraine. I'm here for 5 weeks to work with the team, and so I don't speak any Russian, I'm afraid, so you have to understand my English if you do. If you have any problems with the language, just say you don't understand, but if you have questions, keep them for the end. So Marmalade is a company from London. We've been around about 10 years doing mobile technology, mostly games. Right back to the beginning. Remember the N-Gage phone from Nokia that looked like a pie? So maybe you remember this with some of the first games we did on that. So we've been in the mobile industry a long time, and Marmalade is the technology we've built as a result of the time in the mobile game industry. So first I want to talk about some of the difficulties in developing mobile games today. And well, they've always been there ever since the beginning. These are the main difficulties that we see, and they're basically summarized as sub-fragmentation, but 3 different kinds of fragmentation that you experience if you develop mobile apps today, or mobile games specifically. First of all, tool fragmentation. Who's done mobile app development in here? And who's done simultaneous development on 2 platforms, 2 different mobile platforms? A few. Okay, so you'll be familiar with these problems. Yeah, for every platform you have a separate SDK. Every SDK has a separate compiler, different toolchain, build system, and this is what we call tool fragmentation. And when you get to like 10 different operating systems, it becomes impossible. If you have 5 different versions of Eclipse and 10 different versions of GCC on one machine, it doesn't make any sense. Then you have code fragmentation, which is when within your code base you try and support multiple operating systems with either in the same file you have if-def different operating systems, or you have 2 different code bases and branched, and then you have problems when you try and fix a bug in both at the same time, or you have 10 branches. Some games company have 1 branch for every operating system or every device, and it becomes an unmanageable number of branches. And then you have device fragmentation, the 3rd kind of fragmentation, where within a given operating system, say Android, you have new handsets coming on the market all the time. Each one behaves slightly differently with its own problems or idiosyncrasies that you have to deal with in your code, and you end up with code that has special case for 10 different devices, and then every time a new device comes along, you have another special case. So that's the traditional problem, and Marmalade is our solution to this problem that we've developed. I've been working on it for 5 years now, and it tries to fix all of those problems. First of all, unified tools. So with Marmalade, you just have 1 SDK, 1 compiler, and then that SDK can produce packages for all of the operating systems. So the developer does not have to install the iPhone SDK or the Android SDK, or the WebOS SDK, or the BlackBerry SDK, or the Symbian SDK, or the Brew SDK, or the Windows Mobile SDK. You don't have to install any of that. Unified code, basically you have 1 code base that hits all platforms, and you only compile it once, so it doesn't have different compilations for different platforms. Unified devices means that our runtime basically takes care of all the idiosyncrasies of the device, and when a new device comes on the market, it could be that we need to upgrade our runtime, but you never need to change your application code. So the application never has per device code in it. So what is it, Marmalade, this magic thing? It's a C and C++ based SDK that allows you to build like rich native apps for cross-platform. So you can develop on Windows or on Mac or on Linux. You can use Windows, you can use Visual Studio, Xcode, Command Line, Qt Creator. Doesn't really matter what IDE you use whatever tools you like. You write your code in C and C++, POSIX, OpenGLES, 1 code base, and then we compile that once to an ARM binary, and that ARM binary is native code, and you can debug that on the desktop. We have ARM Simulator debug your ARM code on the desktop with no device. Then when you're finished debugging, you put it on the devices, and you can put it all at once to like 6 operating systems at once, if you want. If you want, you can use our 2D and 3D middleware, or you can talk straight to GLES. And this is used by EA, Activision, Konami, PopCap. Lots of big publishers use this already for porting and for new titles. So we have like Call of Duty, Need for Speed, Tetris, Game of Life, Tomb Raider, lots of big titles, but also smaller titles. So there's a few screenshots of some of the apps. I've got 3 devices here. I've got an iOS, Android, and a Playbook, which maybe you might not have seen here yet. It's a BlackBerry Playbook running QNX. So I'll pass these round at the end so you can play. So that's one of our in-house games that we did, and it runs on all of these. And I have other games. I have Need for Speed as well. I'll show you some more at the end. We split the product into 2 basically. We don't call it a game engine. It's not a game engine. It's not a complete solution, and it doesn't force you to rewrite anything in one particular way. It's more like a platform abstraction and a toolkit on top for building 2D and 3D games or apps. So when new developers come to the platform, they either build games from the ground up using our tools, or you can very easily port all your old C and C++ from PlayStation, Xbox, PC, iPhone, all comes onto Marmalade, and then from Marmalade it goes to all the mobile platforms once you're there. And one of the nice things is that once you've ported your app to Marmalade, when we add a new platform like QNX, this is like 3 months old now, all of the old apps just run with no recompilation. So I didn't recompile that app. I've never seen the source code. My colleague gave me the binary and I ran it on a new operating system. So new operating systems, no recompilation. So the 2 platforms, the 2 parts of it are the platform and the toolkit. The platform we call Marmalade System because it's a system level abstraction, and it sits above the operating system. So you have the operating system is in yellow at the bottom, and then this is the Marmalade System in green, and then on top is the application code, which includes all of your middleware and C and C++ code that you build into your app at the top, and that runs on top of this system abstraction here. So it's I've said most of this already, but you compile it once to a native binary, then you deploy that one binary to multiple operating systems, use standard APIs, so we're not going to lock you in, it's just POSIX, STL, OpenGLEX. We have what we call the extension developers kit for when you have like a new hardware, piece of hardware, like for example gyroscope on the iPhone 4. If we haven't got around to exposing that yet, then you can go direct to the operating system, you make an extension for this special case. And it's very easy to bring in all your legacy C++, like for example, we have things like Lua, Python, the whole runtime just goes on top, game engines, 3D engines, physics engines, that all sits up here. So we've got Cocos 2D, Bullet, Box 2D, all that. And then on the studio side, what we call the toolkit is AirPlay Marmalade Studio, which is all of our 2D and 3D components that you can use if you want. But this is all optional. You don't have to use these components, but they make it easier to build a game framework. So this is how all of our internal games are built with this technology, but external people often have just GLES. So it's up to you whether you choose to use these components. If you do, we have a whole resource pipeline with different kinds of texture compression, and all that is handled for you if you use this. I've got 4 examples of game studios who've used Marmalade in different ways. The first example is PopCap, who make the Plants vs. Zombies and other games. They came to us with iPhone source code, and they wanted to run it on Android and other platforms. And we gave them this training, 2-day training, the same training I'm giving here, and sick them on Monday actually. And then they went and ported their whole game engine to Marmalade, and now these apps are all on Android and probably coming to QNX playbook very soon. This is a HotGem, which is an independent game developer who made this game called Tofu, where you have this stretchy thing. It's kind of a fun 2D casual game, but it's got really good reviews on the App Store, and they wrote it originally on Marmalade, and they have it on iPhone and Android and Playbook. And then Konami came with a console codebase from Pro Evolution Soccer, and they, with our help, converted the console codebase to Marmalade codebase. And so when you get pairs on iOS and Android, that's Marmalade on running those apps. This example, I've not actually seen this myself, but these guys called Trilogy made an application called Harold and the Purple Crayon, which is like an interactive storybook for children on iPad. It's won awards and things. Apparently it's good. I've not played it, but so you can use Marmalade not just for 3D games. So this is Airplay system. How does it work? Like the code loader, which is my speciality. So this is some of the details. I can answer questions about this afterwards if you want. Basically, the ARM binary is compiled once and then combined with assets like images and whatnot into what we call a zest file, which is still completely OS neutral, OS agnostic, the zest file, and it's basically your application, your game, with your code and data in one, but it's not specific to any OS. So we have a tool that then takes that and can deploy it to any OS with one button. So you get IPA file, APK file, sys file, cab file, all from one tool. And the process of making it OS specific is a combination of your zest file and the OS specific component, the loader, which is our system abstraction. And that's about 400K, so that's the overhead of using Marmalade, is your application is 400K runtime addition. But at runtime, it goes full speed. It's not a very good diagram, I'm afraid, but this is your application code, and 97% of the time, it's running directly on the CPU. And only when it makes a system call, like file open, it jumps through the intermediate layer. And this is just like 3% of the time. So you have almost no overhead over native compilation. I mean, it is native compilation, and this overhead is very small, maybe nothing most of the time. For GL, it goes direct, no overhead for OpenGL. And we support currently support ARM and x86 and MIPS, but for architecture you have to recompile. So maximum 3 builds. But for all mobile platforms, it's ARM, so 1 build for mobile. I mentioned the EDK already. Basically, the EDK allows you to access native functionality of the OS before we expose it in the SDK. So, for example, gyroscope, or if you have a library that's built for iPhone, you can actually still use that library in the Marmalade application via an extension. So say that an advertising module that's just for iPhone, you can link it in with an extension. We have middleware partners who build middleware on top of Marmalade. People like Shiba 3D is a big 3D engine, full 3D engine, full game engine. Morphine animation engine. Score Loop is high score online stuff. So almost any game engine or 3D engine can be built on top of on top of Marmalade. And we have for the middleware that's open source, we have this code community on GitHub. Like things like if you just want to help port some middleware to Marmalade, this is where you do it. Once it's ported, we provide packages so you can just use it very easily. And we have this program which is completely optional. Is if a developer wants to come to us and give us their application, we can publish it for them on new platforms. So, for example, smart TV platforms where we have a relationship with the developer of the new platform, we can provide a whole catalog of applications for launch. And if you can join that by joining this program, and then we become the publisher and take 20% of the revenues, you don't have to do it, but it's an option if you can still publish on iPhone and Android, and then we'll take care of the other platforms. This is the idea, that we can build up this big catalog of apps that we can present to a new vendor of an OS. So for example, if Samsung Bada, it was the first one we did, it was Bada, and then we're probably going to do some TV platforms and maybe BlackBerry as well. And that way, if you join that program, you get to be, your app is the first on the device on the day of launch, so you're not competing with very many other apps. You're just competing with the app catalog from Idealworks. So the licensing model is in 3 tiers. We have the professional, which is $3,499 per year for the big publishers who want lots of support. Then we have the standard license, which just the only thing it doesn't have really is the dedicated support. And then the basic license is for indie developers who just want iOS and Android, basically. Which is the basic license is only $199 per year. Yeah. Oh, and anyone can download the evaluation as well. Try it for free today. So our roadmap at the moment, the biggest thing we're doing at the moment is what we call native UI. Currently, you can't use native widgets in Marmalade. We're trying to fix that by having a native widget set abstraction, so you can actually draw real iPhone controls on in your app. We're making a new version of our web view where you can do web view in combination with GLES. And then you'll be able to build HTML5 content into your native app, so you can have hybrid. And we've got the new smart TV platforms coming out, including some smart TVs with 3D, so we have 3D support in there, like visual 3D. And then we have a desktop deployment for Mac, Linux, and Windows, which is things like the Mac App Store and the Chrome Store and all the desktop stores that we see coming out soon. One thing I really want to do here is, I don't know if any of you guys have heard of this native client thing from Google, NACL, NACL. That's what I want to do this using NACL, because I think that's really exciting. But I haven't done it yet. Okay, that's me. Questions? Did everyone understand that?
We all understand, but
you said that Marmalade is something like toolkit. And what about developing applications, not just games on Marmalade?
Yeah, we do that as well, but our speciality is games, and I just spoke about games because this is the game day. But we have a UI toolkit today of our own, but it's not native UI, it's custom UI, Marmalade UI toolkit. And in the roadmap we have native UI toolkit going forward, so we'll be able to develop full native UI business applications as well. Yeah.
Have you access to Android UI components, because it's Java drivers?
JNI. We're native on Android, and we use JNI to communicate.
Java native interface?
Yeah, native interface, yeah. Already on Android we use a lot of JNI because we need to already today. I'll pass these around.
So USDT has been published on GitHub, but what about
No,
the tool?
no,
Or
just
Just middleware.
just the middleware
just
components.
middleware.
Open source, like you know, like a JPEG library or XML library or JSON library.
So it's closed source. If you even buy the license, it's still closed source
Yeah.
stuff. Yeah.
Yeah,
You have access.
maybe one day it won't be, but today it is.
Okay, and as far as I remember, there was a platform called Brew, which provide like C++ environment IP for different kind of platforms. Yeah, it's something similar, but more like widespread and modern platforms. I can go.
Brew
So
is, we did Brew a long time ago, since the beginning we had Brew.
Uh-huh.
It was very popular in 2004, 5, 6.
But now it's
But yeah, in America, it's just in America. And that was native code, but that was one of the reasons for starting this, is because their compiler was so broken. They have C++, but no virtual functions. Virtual keyword didn't work. So the broken compiler. So we fixed it. So we had a good, we fixed their broken compiler.
So basically, you fix the problem with Brew.
Yeah.
The compiler with that branch.
That's So Brew was limited, and they might come out with Brew 2, but so far we haven't seen much evidence of Brew 2 anytime soon. But we have support still for Brew in the SDK. It's just deprecated.
And you mentioned Shiva as the engine which uses Marmalade. But as far as I remember, yeah, Shiva is able to deploy on all Windows, Linux, Mac, or iPhone, Android, right? Everything. So they're using Marmalade for that packaging.
They're using Marmalade for their mobile.
For the mobile.
Yeah.
Okay.
Yeah.
So they have some scripting and high-level tools,
Yeah.
but underneath they use Marmalade for all the mobile stuff.
Yeah. When you compile it, what the end result is Marmalade binary.
Oh.
Yeah. Only on mobile. And maybe
So basically
not,
when you
maybe not even iPhone as well. I don't know. Maybe they have a special iPhone pathway. I don't know.
well, but Marmalade is there somewhere. Yeah?
Somewhere they have.
When you
We have
buy
them.
Shiva, you get Marmalade somewhere.
Or you maybe upgrade or something. I haven't done it myself.
Okay.
But when you go to finish your Shiva, there's like a Marmalade box somewhere that you tick somewhere.
Okay, thanks.
Do you have plans to support Ego operations?
Yes. Yeah, we have Migo support, but we don't ship it because we don't think it's basically cancelled. As far as we know, but we have Migo support. We did Need for Speed for the N9 this game. Yeah, we can add new platforms in about 2-3 weeks because the system abstraction is so small that we only need to port about 6 C files because everything else is outside the abstraction. Obviously debugging takes a lot longer, but we've had Migo support for 6 months. And we always look for new platforms too. So as soon as there's a new platform, we'll jump on it. Yeah.
Do you plan to support Windows Mobile?
Yes. Well, we already support Windows Mobile. What we don't support is Windows Phone 7. Windows Phone 7 is so far is bytecode only, and we need native execution. So as soon as Microsoft allow us a backdoor to run native code, then we'll support it. As I understand, underneath the bytecode, underneath the VM, it's exactly the same as Windows Mobile 6. So we already have code that will talk to the underlying layer. So we're knocking on Microsoft's door to make them allow us, and so far they said no. But I think if enough pressure from game developers, one day they might say
Who
no.
cares about Windows anyway?
Yeah.
These
Well,
days, especially
I don't think
mobile.
anyone would except for Nokia. Nokia is probably going to
That's
change.
strategic mistake.
I have some cards if anyone wants to card. A lot of cards here if you want.
And what's about speed of for example, I have some program on Java for Android and similar program in Marmalade. It will be faster.
can't say for sure, but most likely just going from Java to native is probably going to get a lot faster. Certainly, we do our best to be as fast as possible because we come from high-performance 3D games. We want maximum frame rate, so we've always concentrated on performance. Yeah, certainly going from a Java game to a native game, you're going to get faster. Yeah.
What about applications except games?
Yeah,
For example, Android has powerful system for different layouts for different screens. If OpenGL, it's clear, it's camera position. What is that's all. But what about other applications?
Well, we have, like I said, we have a UI framework. It's not the same as the Android framework, but it has screens and buttons, sliders, checkboxes. We have our own custom one.
But one thing is controls, but other thing is layouts.
Yeah, we have our own layout.
It's very special for Android.
No, we have a generic one that works on all platforms. That's today. But in the future, we're going to expose the full power of Android UI and the full power of iOS UI. But then you have to have different layouts, different code paths within your. Say, if I'm running on iOS, then do this UI. Otherwise, do this UI. So you have multiple code paths, but that's because you want a very specific look. If you want the same look on every operating system, then you can go with a generic solution.
But if screen is small, you can't show same thing as on the tablets.
Yeah, no, I mean it's the same problem with all UI solutions, like with widgets, and we're working on solving it in a way that is equal or better to the Android solution or the iPhone solution. I think on iPhone you need to have two different layouts, one for iPad and one for iPhone. Is that right? Basically.
Yeah, definitely, because
So we'll do the same basically. Yeah. So you have small, medium, and large, maybe something like this. But this is all coming.
And what's about special libraries, for example, DirectX? If I want to use DirectX, it will be work on. Will it be?
You use
on Windows Phone 7, maybe they have DirectX, but we don't support that yet. But no other mobile platform has DirectX. So it's GLES, and that's all. GLS 1, GLS 2. Yeah. Has anyone downloaded this before, ever? No?
So look and feel on different platforms will be like native for your platform. I will see like Android application as an Android application. I will feel like Android application. Yeah.
Are you talking about
the UI? Yeah, all buttons, all that kind of controls.
once we do native UI?
So right now it's like generic.
Right now it looks like Marmalade UI on all platforms. So you get consistency.
You got like
so
TK or something like that.
So you have iPhone and Android, it looks identical, which is good maybe. But some people like it to look right like the OS. Yeah, so you have to choose.
You have to choose,
yeah. So we're going to provide the choice in the next release. There'll be a choice. You can either choose generic, look and feel, or specific. If you choose specific, you have to do more work per platform. Maybe, I think. But not too much work. And it's the same code base, the same IDE, so you don't need to have a Mac. That's one of the great advantages of this, is you don't need a Mac to make iPhone games. We have the Windows only SDK. It works fine.
It looks more cool than Need for Speed on BlackBerry.
It's better than on the
You know, Need for Speed here. Need for Speed on the cover, BlackBerry.
Yeah. The one that comes with it.
Your application looks more cool than.
Yeah, yeah, exactly. No, the original one in there is from EA. This is our one, which is better. So, yeah, you get very good performance. See, you were asking about performance. You don't get that kind of performance in Java.
Sorry, how long is it you shouldn't to recompile application
application for different platforms. But how you separate all the platforms and analyze which platform is using current time?
You can ask the system what platform the name is. Is that your question? So in your code, you can ask which operating system you're running on. But it's all you can't use if-def. You have to use if get system equals playbook. There's no if-def because compile just once. Yeah.
Why isn't Google use Java if native code is faster?
Well, A, native code is faster. B, because we have lots of existing content in C and C++, we don't want to just throw it away. We want to reuse that.
But I think C++ is more useful.
Oh, you think it's better? Yeah, I agree. Yeah, I agree.
But Java is slower.
Well, if you look at what
C++ more popular.
you look at what Google are doing with the NDK, you know the Google NDK for Android, Native Development Kit? It's how you write native code on Android. It's called NDK, and they're making that better and better, so that game developers will be making more and more native content. So even though Android started off as Java, they're moving to a certain extent away from Java because they're making the NDK. They recently added a feature where you could write an application with no Java at all for Android, fully native app. Okay.